XDF, and I'm looking at what's what from the RunCode competition in early November. This was the only hard challenge I managed to finish during the competition. It's also an interesting one because there was a mistake in the challenge that made it the randomness was not as random as they were hoping. So it actually was there was a way to shortcut it. I actually didn't find that in the challenge. If I get time at the end here, maybe I'll go back and look at that. So there's actually two versions of it. I got what's what, and they got what they republished it after the challenge as what's hard mode, which is exactly the same challenge. Just this is on port 9005. This one's on port 9004. So both are still up, but they just fixed the randomness issue. So and I'll show a little bit of that as we get going. Our internal cyber threat intelligence team found the following socket when listening. Blah blah blah. It's not important. Hit the socket, follow the directions, and win some internet points. Here's the critical part here. It looks like the socket is mocking us and wants us to find the incorrectly coded data and pick the correct entry. We will. Oops. Let's see. Always worth starting with just using netcat and seeing what we got here. Welcome to the encoding checker. Review the 4 choices and determine which one's not correctly encoded word. Return the number of the incorrect entry to win the round. Win all rounds for 6 internet points and a flag. So if I enter 0, oops, I probably timed out. If I enter 0 here, it says nopes. Try 1. So nopes, and then round 1. Keep firing. So you can see. So basically, I got to figure out how to get all of these right. What's interesting, if I go for a while here, does it ever stop? Certainly a fair number of them. Okay, here you go. Rounds 1, 10 out of 32. Keep firing. Goodbye. So it looks like there's going to be, at least this time, there was 32 rounds. I'll probably build it that I don't need to assume that number of rounds to succeed. But anyway, okay, so what are we looking at here? 4 different things. For sure, as I go through here, I'm noting right away, they seem to be not shuffling around, which is to say, the one that's 0 seems to be the same kind of encoding each time. 1 is always, let's see, 1, 2, 3, 4 bytes, 32 bits of hex. 2 looks like a base 64 based on, just the character set, uppercase, lowercase, equal signs at the end. And then this at the end here looks like it's hex, and it is, let's see how many characters that is. 33, one of those is the new line from Echo, so 32, that's probably an MD5 hash. So I can start to think right away. The only one I haven't immediately identified is this one. And just by the fact that it's all capital letters and some numbers, and it's still got this equal signs padding, but it's got up to 5 or 6 of them, you could do some internet research. That's base 32, I'm willing to bet. So let's pick one of these and try. Let's start with what we think we know. So this would be base 64. Let's see if I can select it. Copy that. Echo base 64 minus D, and it's a word abolitionist. Okay, that might be something. Let's try this one. If we echo that into base 32 minus D, we get the same thing. So that's a good sign. That's a good sign that both we got the encoding and that we are, those are probably both correct. Let's see. So if we echo that into, let's see, with it minus n, so there's no new line, MD5 sum, 13C, that looks very similar. I haven't checked all the it's hard to say exactly what's different, but I can say pretty confidently that is an MD5 hash. And then, this is a 32-bit thing. The thing that immediately jumps to mind is a CRC32. Let's see if we can check that. How did I do that in Bash? That is not something. Oh, can I just? Oh, that's what they want to do. I can't do that. Go long string. Well, that's something. Is there? Oh, let's see. Process. That'll work. Let's try that. So we want to get rid of the long string and put in abolitionist. And it does not match our thing. Let's try getting rid of the new line in echo though. It doesn't match now, so this could be the one that is wrong. Oh wait, I'm looking at the wrong one. It does 76 BEF A95. So that's looking solid. So that is a CRC 32. So cool. So I didn't find any in that line that were wrong. Let's find one that I got right and see if we can figure out what's going on. Round one, keep firing. So the wrong one in this case was here. So we'll try this echo. Whoa, that's not what I wanted. Echo U, the last one, into base 32 decode and immolate. Okay, and if we echo the same one, with base 64 decode, immolate. Okay, that works. If we echo immolate into oh, and we gotta get rid of the new line. So the reason it doesn't matter on the base 64 and base 32 is because these decoders are smart enough to just remove the new line character. But when you're doing a hash, like an base 64, there is no smart enough. You might want the hash with the new line character, or you might want the hash without the new line character. But either way, it's a different result. So it's really important that you give it what you want. That applies to most computer things. That looks good. Oh, but the correct result was 1. So let's see what happens when we do this. And we want to get rid of the... Oops. Whoa. Let's see what we got here. CRC, I don't know exactly what happened to my terminal there, but so A181754. Oh, and it says 56. So it's subtle, but it's wrong there. That's it. I think I understand the challenge and what I need to do. Let's start up Python. So this will be called what's.py. Start with our shebang. We are going to need, what are we gonna need? I'm pretty sure in the competition I solved this one before I knew Pwn Tools was available. I'm gonna grab the code for the Pwn Tools fix. So just to make it easier, I showed in the last video for the JSON sorting socket, I went back and converted my solution to Pwn Tools. This time I'm just going to work with it natively. So I need to do os.environ term equals xterm. And then I can do from Pwn import star context log level equals error, so I'm not printing out extra stuff. I'm also going to need sys to take in the socket. So first thing we're going to do is we're going to do remote sys.argv1 and sys.argv2, and that one's going to be an int. So we'll do that. So that gives us a connection. Now go up to the top here. We basically want to skip through all of this initial garbage. So we will do s.receive until, and this is where Pwn Tools shines, because doing this there's no receive until function. I have to write myself kind of a really poor one. And this will just make it way easier for me. So I can just do sick internet points and a flag. So be there. And let's go ahead and capture the new line as well. And I'm just going to capture that and throw it away because I don't need it. And so then I can do while true, because now I'm going to loop over all these things. And I'm going to say challenge line equals s.receive line, another thing that doesn't exist in outside of Pwn Tools, really handy. Okay, and so now let's see, we can split it on. So we'll say, again, I have this tendency, I'm going to want to do this all in one line. I probably should break it up. So what's the easiest way to do this? We'll do B32, comma B, comma CRC32, comma B64, comma MD5 equals, and now we have challenge line dot split. Actually, I have a better idea. Let's do it this way. challenges equals challenge line dot split. First, we're going to split it up on space. So now we have each of these there. And then I can do, I'm going for one line. So that's going to split it on space, but I don't really want to split it on space. I want to then split off these things at the beginning. So what I'm going to do is I'm going to do a x for x in, like that. And I'm going to do x.split, like that. And the split is going to be on the dash character, and I'm going to want the last, I guess 1 and -1 are the same here, so we'll save characters. And that should give me just the encoded or hash, the encoded value or the hash. So that's nice. That'll give me challenges. Now I can start to test them. And so this is what I will do is I'll test each one. So the easiest one, let's see. So we can come up here. We're going to need import base64. That library actually is going to give us 64 and 32-bit decodes. So we'll say try, because we might break sometimes. B64 word equals B64 decode. Oh, sorry, that's base64.b64 decode. And then we're going to do challenges for 64. It's going to be 2. And so if that decodes, that'll be good. Except maybe we'll just do at this point, really, if that fails to decode for some reason, that probably means that the error is there. So what we'll do is we'll probably have to do something like this. Done equals true. And then down here, dot send line 2, because 2 was the wrong one. If we failed here, we're going to move on. And then we'll say done equals true. That should be false, because we don't want to like do some sending later. So now we'll do another try. Base32 word equals base64.b32 decode. Challenges, and that is 0. And same thing. In fact, you probably just hit 3YY to yank 3 lines, and then come down here at P. And the only difference is now I'm going to return 0 instead of. I'm gonna guess they probably want me to put this as a string and not as bytes, or not as an int. So we'll do that. Okay. So at this point, if either of those fail to decode, we're just going to send and be done. Otherwise, we can keep going. So if not done. And now we're going to do, so if those two things are equal, then we know that it's one of the other two things. So we'll start there. If B32 word equals B64 word. And then we'll come down here and we'll probably need an else there as well. I really got to figure out how to fix my automatic indent. It's pretty annoying. I have to hit space every time. So now what's the next thing to check? So if those two things are equal, that means that those two are not the one that's at fault. So we'll do an MD5. So we'll come back up here. We need hashlib. Import hashlib. And now we can do hashlib.md5 of either of those, because they're the same. B32 word dot hex digest. That's what prints out the value. And so this is all another if statement. If that equals challenges, and the MD5 is number 3. So if that works and is right, then we can s.sendLine, and in this case, so we know that those two matched and the hash was right, so it's 1. I don't even think I'm going to need to check the CRC32. Else, so now this means that the hash did not match. Send line 3. So now we're sending 3. So that handles the case where both the two things decode and work out to be correct, I guess that's probably. So now let's come back down to our else here. So now we're in the case where the two words were different. So we need to figure out whichever one has the MD5 hash matching is going to be the one that's right and the other one's wrong. So we will do if hash lib dot MD5 the 32 word dot hex. I guess I really could have just yank paste, delete that. So if that matches, if the hash of the 32 word matches, we'll send line. And so the 32-bit word and the MD5 matched, but the other one didn't, so that'll be a 2. Else dot send send line. So now this is the case where the 32 word is off, so it didn't match. All right, and I think that works. So let's see what happens here. Let's think about this for a second. So we're going to receive until that point, then we're going to receive the line, then we're going to do our check and send the result back. So what comes back after that is either going to be nopes or round 1 keep firing. So that will be at the top of this back at the top of the loop here when we get challenge. No, we need one more line here. So let's do, because either way, even in the 30-second case, we're going to still get a nope, round 1 keep firing our nope. So we want to receive this line pretty much no matter what. So we want to be back here, 1, 2, 3, 4, s dot receive line like that. So now we just received our input here. So the next thing that comes is either going to be a next challenge line, or it's going to be say rounds 1 blah 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 blah. So let's come down. Oops, I did not mean to do that. Let's go up here, and that's going to be back at the top of our loop where we receive the challenge line. So if rounds 1 in challenge line, I'm guessing my bytes versus strings is going to be a mess, but we'll deal with that. We'll break. We'll get out of our loop because we're done there, and then we just want to receive all and print the results. So we will come down, print s dot receive all dot decode. At least that part's going to be good. Okay, let's see how many places. I just wrote the whole thing with no interaction. That is strange for me. So let's give it a try and let's see how many different places it'll break. So what's what pi. We're going to need to know what we're connecting to. It doesn't matter whether we connect to the broken one or not because we're not abusing that. All right, line 41. Of course, it helps if you put that after your else. Let's see what else we got. Line 46. Need a closing parenthesis. Okay, rounds 1 in challenge line. Line 16. Make that bytes. Challenges, next line. So we're going to, let's see. You know what we can do that actually make this, well, let's see. Are we going to need down here, base 64 decode and stuff likes to have bytes. So we want this to be in bytes. I was going to say, oh, we'll just decode it right at the beginning, but we should just work in bytes because that's what the base 64 library wants me to do. So we will make that bytes and that bytes. Let's see if that fixes it. Hash lib not defined on 34. All the typos. Hash lib not defined on 39. Oh, because I was like, man, I made the same typo exactly twice. It's because I copied that. All right, that made some progress and it didn't work. So what's awesome, and a trick I've learned, especially with RunCode stuff, but anytime you're working with, I do this in Hack the Box stuff too, whenever you're working with a non-encrypted socket, so if it's HTTP or if this, anytime you're just connecting with Netcat, like go ahead and just, run it again, but put a packet capture going. Whoa, did I just crash Wireshark? Maybe I did. I might need to run this as root. Let's try one more time. Cool. And now run that. And let's see what we got. So we can follow the stream. I don't know how to make this font any bigger. Oh, that's I do. I'm rolling. Okay. So we are sending back 333. Nope. Our logic is clearly wrong here. Somehow we won. Let's see. If we send 3, we get nopes. Cancel. 3, we get nopes. 3, we get nopes. 3, we get nopes. 0, we're getting nopes. 3, we get nopes. Let's come down. Nope. We won. Huh. That is strange. I would not have expected that to happen. So we send 3 and we get a correct. 3 incorrect. 3 nopes. We're only sending 3 and 0. We do send a 2 down here at the end. We don't ever send a 1. That's strange. So let's be a good check. So let's do the first challenge manually here. So we know this should be base 32. Echo, actually, let's go to a new window. Echo that into base 32. XD. Okay, I got a word. We can do the same thing with the base 64. Now, our code found this sent back 3, meaning it didn't like the MD5. So okay, so we're good so far. We agree that we agree with the code that that prominently came out of both of those. Now, if we echo that -n into MD5 sum. Okay, 7B 70 DAOD 4432. Oh wait, I have a better idea. This is lazy, but let's copy that and echo it. That's the 1 into MD5 sum, and we will echo that. Echo. I was going to say we can just echo the whole thing, but we can't really because there's that dash and stuff. Let's see, and we'll echo this one to MD5 sum. They're the same. Okay, so the MD5 is good because I just checked. Basically, I took a hash of what I got, what I calculated, so prominently to that gives this hash, and what came in the packet matches. So the answer here should be 1, and I'm getting 3 for some reason. So let's go back to our code here. Where do we decide between 1 and 3? Right there. That's line 34. So B minus C break 34 minus C, C, and there we go. We are at line 34. B32 word. That looks good. B64 word. That looks good. Hashlib MD5. That looks good. I already know the answer. I just figured it out. Challenges -3 is going to be in bytes, and it's not stripped. So let's come down here and say that decode. Oops. Stripped. So basically what's happening is Python is comparing this to this and saying, no, they're not equal. They're not even the same type of thing. This one's a bunch of bytes with a new line on the end. This one's just a string. So now if we do that, that should look much better. We're probably going to want the same thing right there. Quit. Let's run that again without, see what we get. Ooh, index out of range. Let's look at that. Let's go ahead and refresh this and run that again. Follow the TCP stream. Round one. We're looking really good. In fact, we get to the end. So it's really just the end. We already got, here's the flag. We've correctly got the flag. I guess I should make that bigger so you can see it. But every one of these things is 1, and right there is the flag. So this is not a matter of, this is just a matter of somehow things got messed up where I I wonder what round 1 keep firing. So that probably came in. That should be this line. And then we're back at the top. Challenge line equals receive line. Oh, of course, rounds 1 isn't going to be in the... Okay, so what we really mean to say is, what we really should do is, because we don't, let's pretend we didn't know the flag yet. What we really should do is, if challenge line, if not, challenge line dot starts with 0 dash, like that, then we break. So if we get anything that, if we read a challenge line and it doesn't start with 0 dash, then we don't have a challenge line. We have something else. So we're really, that's, let's see what we get here. That looks better. You're a wizard, Harry. And I'm gonna just be a little bit OCD here and do strip. I don't like the prints twice because there's a new line on the string and there's a new line with the print, so that makes me go blah. And so there we go. We got you're a wizard, Harry. This script will solve it. Let's come back up here and let's go down here and select RunCode, what's what.py, submit. And this should run any second. You can see I have one down here. I took my original script that I had created and threw it up. When they released the new what's what hard mode, I threw it in there to make sure it worked, and it did. So I did solve it the non-cheat way. And there we go. We solved it again. That was a fun one, and I thought that was one that was honestly kind of easier than some of the ones that ended up in the other categories, even though this is the hard one, quote unquote. And hopefully you get a chance to see what really shined here is PwnTool's ability to, just do, they're little things, but this little function like send line, that's not a big deal because you can just do a send and then add a new line to the end. That's okay. But like receive until here is really handy. Receive line, just receiving the challenge line. Again, you could do your own little receive until and receive until a new line, but I mean, it's convenient. It's nice. So it's good to have PwnTools available. I think that's it. I guess I can take a peek at the cheating way, or the original one. Come back up here. What's the easiest way to? I think the main thing to check out was, I ran this several times against this socket, and every time I ran it, it started off with, let's look, OBZG and MNUG. Here it is, the same OBZ, OBZ63, so it's doing the same things in the same order every time. And so I'm wondering if the answer is just to calculate the order basically, and it's the same broken order every time. So you can just try all 4 things in each of 4 things until you figure out what the order is, and then you just send up a solution that sends 1, 3, 5, or whatever. You can see this if we switch to port 9005, and it's different, so it's a different challenge every time. And so I'm not going to go too far down that rabbit hole because I think the intended way was much more fun. But that is it for this one. Thank you so much for sticking around to the end, and I will talk to you next time.